All right, we are working into our last unit. So we've already done Pythagorean theorem in Unit 9. Now we're moving on to triangles and congruent figures. And you will use a lot of this when you're going into geometry next year, integrated math 2. And you'll know a lot of these terms that you're going to use in these next 3 units, 3 sections. Okay, so first let's talk about different types of triangles. So acute triangle is when all 3 angles are 90 degrees or less. So you can have an acute right triangle, that's possible. But an acute triangle would look something like this. Okay, so maybe this is 65, and this one's 55, and this one's 60. That could be an acute triangle. Obtuse happens when one angle is greater than 90 degrees. Okay, so that's going to be one of these kind of spread out triangles like that. And let's say this is 100 degrees. This would be 50, and this would be, actually let's flip that around. This would be 50, and this would be 30. Okay. Triangles always add up to 180 degrees. We know that. This would be 50. Okay. Oh, sorry. Let's clarify that. 30 degrees. Okay. Then a right triangle, of course, we know means that one of those angles has to be 90 degrees, and that's always shown by the little square. So this would be a 30, 60, 90 triangles. 30, 60, 90 triangle. One angle equals 90 degrees. Okay? So there's some more specific types of triangles. So a scalene triangle just means it has 3 unequal sides. Okay? So a lot of triangles that you see are going to be scalene. Okay, but they can come in all different shapes and sizes. Scalene can be right triangles, scalene can be obtuse, they can be acute, as long as those sides are unequal. An isosceles triangle happens when it has 2 congruent sides, meaning 2 sides are the same length. And we show those lengths by a little notch like that. And also, these 2 angles that are directly across from the congruent sides will also be the same. So 2 congruent sides and 2 congruent angles. Okay. Equilateral triangle, you can see that kind of looks like equal right there, means that all 3 sides and all 3 angles are congruent. So that ends up being a 60, 60, 60 triangle, but the sides can be all different sizes. So you could have one that looks like this. You could have one that's bigger. But all 3 sides are the same, and all of the angles are 60 degrees. Okay, easy enough. Okay, so let's get down to a theorem. And this is for the isosceles triangle. So we're dealing with this triangle right here. So we've got 2 sides are congruent. Then the angles opposite those sides are also congruent. Okay, so big thing with triangles are the sides are directly correlated to the angle that's directly across from them. Okay, so if these 2 sides are congruent, then the angles directly across from them will also be congruent. Okay, so I'm going to draw a picture of that. So if we have the sides, let's say that this is triangle ABC, and we know that AB is congruent to AC, then these two angles right in here will also be congruent. So what we know is, unless my triangles look similar, but that's okay, that angle B and angle C are also congruent. So angle A is congruent to angle, angle B, sorry, I meant to say. Drew it correctly and then said it wrong, is equal to angle, it's congruent to angle C. Okay, so if we take the converse of that, converse, remember with not type of shoes it is, but it's when we flip something around the other way. So if two angles of a triangle are congruent, then the sides opposite those angles are also congruent. So let's So let's say you have, let's call this triangle DEF, and you're told that angle D and angle F are congruent. Okay. Then I know that those sides are directly across. Then I know that these two sides are also congruent. So then I know that DE is also congruent to EF, or sorry, FE. Okay. All right, so let's put some math to it. So remember, there's always 180 degrees in a triangle. We know that now. And so in this first triangle, we know that 48 takes up one of those corners. I know because those are my congruent lines that this side is directly across from X, and is congruent to this side, which is directly across from this angle, which now also has to be X. So I just need to subtract 180 minus 48, or 180, let's do it this way, 180 equals 48 plus 2X. We can solve that really quick. So we subtract 48, we get 132 equals 2X, divide both sides by 2, and my X equals 66. So each one of those angles equals 66 degrees. Okay? Now, what if we know in our middle triangle, let's give those lengths each a side. 2x plus 3 and 4x minus 7. So what do you know about this side and this side? Well, we know that because we're told by these little hash marks that they're congruent, that means that they are equal to one another. So we're just going to set them equal and then solve for x. So I'm going to subtract 2x from each side and then 7 from each side. So I get negative 4 equals 2x. So x equals negative 2. A lovely Abby has just come in my room. I should make her do the rest of my video with me. That would be a nice punishment on a Friday afternoon, because Friday school wasn't bad enough. Okay, so we'll do oh, I just got the face. Very nice. So let's do the last one. So we've got x squared plus 3x and 40. So again, we know that this side is equal to this side, so we're going to set that up. X squared plus 3x equals 40. Abby, in quadratic equations, you always have to have them set equal to what? 0. Oh, she remembered something from all of last year. Very nice. Thank you, Miss S. Okay, and then we just need to factor that. So we need something that adds to 3 that multiplies to negative 40. So we would get x plus 8 and x minus 5. So our possible solutions are x equals negative 8 and x equals 5. Either one of those solutions would be okay because we're not finding a length, which we couldn't have a negative length, but we are finding a value for x, which is okay. Okay, so let's go to equilateral triangle theorem. So what that says is if a triangle is equilateral, then all sides are congruent. All 3 sides are congruent. Okay, so we've got this, and by the tick marks I know that they're all equal. And then I also know that all of the angles must be equal. And that means they must be 60 degrees each. So, because I know that directly across they're going to be equal to one another, then I know that all of my angles also have to be equal to one another. Okay. Conversely, equiangular means that all of my angles are equal, are congruent, and they must be 60 degrees. So, if I'm given a triangle where all of my angles are equal, then it makes sense that all the sides must be equal, must be congruent. Because they're all directly across, so it's just the inverse of what we had up there. Okay, so let's get a couple definitions down now of congruent figures and corresponding parts, because you're going to use this a lot in geometry, aren't you, Gabby? Yes, she's very happy about being included on this video. Okay, so congruent figures happen when all sides and all angles are congruent. Not some of them, not most of them, has to be all of them, otherwise they are not congruent. Corresponding parts just means that the sides and angles that correspond with one another. And you'll see what we mean a little bit more in a minute. Okay, so let's start with this. So this way this is written is how you're going to see things a lot. So triangle EFG, so EFG is congruent to ZXY. Okay, and if that's true, that means that all three sides have to be the same, all three angles have to be the same. You're going to see this, and we can start with EF is congruent to ZX, so those can get our first tick marks. FG is congruent to XY, and then coming around from G to back to the beginning, so GE is congruent to YZ. Okay. So, and it's important to look at the order that you're going in. So if you want to, you can use either the angles or the sides, doesn't matter, but you need to go in the same order. So if I'm starting with first side of angle 1 and I'm going to go to 2, then to 3, then I'm saying that triangle RQS, so I'm going first tick mark to second tick mark to third, would be the same as, now I've got to go from first tick mark to second to third, is congruent to triangle BCD. So I'm going from first to second to third. Okay. If I wanted to use the angles, I could do that too. If I started at angle RQS, 1, 2, 3 tick marks, or at BCD, 1, 2, 3 tick marks. Okay. So corresponding parts means which sides go together. So let's look at this one. If I looked at RQ, and this might kind of help. So here's our first side, right? And the first side in our corresponding triangle would be that. So I could easily pull just that part out and say that RQ is congruent to BC. Okay. Likewise, I could say that my two angles that have the 3 tick marks are congruent to each other. So I could say angle S is congruent to angle D. And these are going to be really necessary when you are working on your proofs. Okay? All right, so let's try a few. So if I know that that triangle RTS is congruent to TRG, I need to know which side goes with SR. And it's important to look at the order of things too. So S and then it goes back to R at the beginning. So we wouldn't have TG, it would actually be G back to T. So be congruent to GT. Outer corner, back. So we went S to R, it's going to be G to T. Okay, if XZ, kind of the same thing again, XZ would be congruent with JZ. And then we're told that LMN, and it helps sometimes to label that too. Okay. Or you can draw yourself a picture. You can always draw yourself a picture on number 2 if you needed to. LMN, so I'm going to say LMN, and I can do 2, 1, 2, 3, is congruent to IHN. So IH, HN, and back around. So I would have 1, 2, and 3. So MNL, now I'm going from 2 to 3 to 1. So it would be congruent to HNI. Because I'm going from 2 to 3 to 1. 2 to 3 to 1. So they're congruent. Okay? All right, that's it for 9-2.